Hello algebra students, I'm going to do a couple of quick division problems just because even though we'll go through this in class, I want to have this out there for kids who miss, things like that. So, long division, something you learned how to do a long time ago dealing with numbers. If I had 504 divided by 8 and I was in 3rd or 4th grade and I was learning how to do this, I would use long division. I would set up 504 here, put my division sign here, and then an 8 here. Now as far as words are concerned, what's called the answer to a division problem, the quotient, and I have the number that is doing the dividing was called the divisor, and finally the number that was being divided is called the dividend. So just a couple of words for you to remember as we remember how to do long division, starting with numbers. Now when I was dividing numbers using long division, I would look at the first number, in this case the 5 that's in the hundreds place, and I'd think to myself, can 5 be divided by 8? Well, the answer is no. So then I add in the 0 and say, can 50 be divided by 8? Well, sure, I know that 8 goes into 50 about 6 times or so. Then when I took 50 divided by 8, I took this number 6, wrote it in the tens place because that's where it belongs, and then I multiply around. 6 times the divisor 8 and I get 48. I run it underneath the 5 and the 0 there in the hundreds and the tens place. Now my next step that you learned was that we need to then subtract. So I take 50 minus the 48 that I have underneath, and I have 2. The next step then is I bring down the next number in my dividend. In that case, that'd be a 4. So I'm going to drop the 4, put it right there. And then I repeat the process. I take the 24 that I have here divided by the 8, which is my divisor, and I get 3. 3 times 8 is 24, and then I subtract, and that turns into 0. Now, because I have 0 at the end and there's no more numbers here, I would say that 504 is divisible by 8 because when I divide it, I get 63 with 0 for a remainder. Now, let's say that my numbers have been a little bit different. I'll do this same problem. We're just going to change the numbers just a little bit. We'll call it 505 divided by 8. Well, as I do this, 50 divided by 8 is still 6. That's still 48. Subtract to get 2. Drop the 5. 25 divided by 8 is 3. 3 times 8 is 24. But now, when I subtract, I end up with a 1 at the end. And in 3rd grade, you had a couple ways to write the remainder. Maybe you wrote it as R1, like 63 remainder 1. At some point, maybe in 4th, 5th grade, you started to then add 0.00, and you maybe would have decimal answers. And that was fine too. Another way that you could write your remainder is you could write this answer as 63 and 1/8. So I could write my remainder as a fraction of the divisor, whatever it happened to be. Keep this idea in mind as we work with polynomial division. So our first example of doing polynomial division, here I have my polynomial being divided by a monomial, a single term. Well, here's how I'd set that up. If it's just a monomial, rather than using log division, what I might do is I might just take each of these terms and divide the whole thing by 6n. Now what happens when I divide everything by 6n, my monomial, is essentially I'm dividing each of these terms individually by 6n. So 30n cubed divided by 6n, 6n squared divided by 6n, 2n divided by 6n. It's as if I'm distributing the division part of this. Now when I divide each individual term, what I do is I get to simplify each expression. 30 divided by 6 is 5. N cubed divided by n to the first will be n squared. So there's my first term. The next one, 6 divided by 6 will be 1. N squared divided by n will be n. So 5n squared plus n so far. And the last one, 2n divided by 6n. Well, the n's will cancel, and 2 divided by 6 would be 1/3. So 1/3 would be my final term. And I would leave this as is. Nothing I can do. I can't combine these. They're not like terms. So this would be my quotient when dividing by a monomial in this case. Next example is a little trickier because now I'm going to be dividing a big polynomial by a binomial divisor. Here's how I'd set this up using long division. First of all, my divisor, 3b plus 1 will go on the outside. My big division sign goes here, and that will be 3b to the 5th minus 11b to the 4th. Minus b cubed plus 4b squared minus 20b minus 4. This is a really big one. That's okay, we can do this. Oops. So, move this up a little bit out of the way. When we divide polynomials, like to take it step by step. The first step is I would need to take the first term in my dividend and divide it by the first term in my divisor. I'm going to either write off to the side. This is what I'm doing. I'm taking 3b to the fifth divided by 3b. This divided by this. Well, that would give me b to the fourth. 3's cancel, I'm left with b to the fourth. So b to the fourth is part of my quotient. I'm going to write it above the b to the fourth term in my dividend. Then, as I did with the long division with numbers, I multiply around. So my next step is to take b to the fourth times both of these terms. b to the fourth times 3b would be 3b to the fifth, which is nice. b to the fourth times 1 will be b to the fourth. Now when we did long division with numbers, our next step was to subtract. So we're going to do the same thing. We're going to subtract. But understand, you're subtracting a polynomial now, 2 terms. I have to subtract each of these. Now sometimes that gets tricky because we get nervous about am I subtracting a negative, a positive, whatever it might be. So what I like to think of it, I like to say change the signs and combine. Change the signs as in if I had x minus 1 minus x minus 3, let's say. Here I'm subtracting a polynomial. What I taught you to do is to distribute the negative sign and then combine like terms. So that's the same thing we're doing here. We're going to change the signs and combine. So change the signs, negative, and this becomes negative, and combine. Well, 3b to the fifth minus 3b to the fifth goes away. That's the idea. Negative 11b to the fourth minus b to the fourth becomes negative 12b to the fourth. The next step is to drop down the next term. So here comes negative b cubed. And then I repeat the process. I take the first term divided by the first term. Well, that's going to be negative 4b cubed. And then I multiply around. Negative 4b cubed, that'll give me negative 12b to the fourth minus 4b cubed. Once again, our next step is to change signs and combine. First two cancel. Negative 1 plus 4 is going to be positive 3b cubed. And then we drop down the next term. It becomes positive 4b squared. Repeat the process. First term divided by first term. That will be b squared. Plus b squared is my quotient. Multiply around. 3b cubed plus b squared. Change the signs and combine. Goes away. 4b squared minus b squared, 3b squared. Drop down the next term, which is negative 20b. Repeat the process. First term divided by first term. 3b squared divided by 3b will be b to the first. Multiply around. That's going to be 3b squared plus b. Change signs and combine. We get negative 21b. Drop down the final term, which is a negative 4. Repeat the process. Divide this, negative 21b, by 3b. That will be 7. Multiply around. I'm going to have negative 21b plus 7. One final time. Change the signs and combine. Negative 11 we get. Well, negative 11 happens to be our remainder. So negative 11 is going to get written in my quotient way up here as the remainder. Now when I write the remainder, I'm going to add in another term. I'm going to add in negative 11 over my divisor. So I write my remainder as a fraction of the divisor. And here, after a whole lot of work, is my final answer. The quotient I get when dividing a couple of polynomials. So good luck as you practice this on your worksheet.